Okay, so this is page 18, lesson C6, properties of integrals continued. So right here, guys, we're going to talk about interval addition and subtraction. And let's do let's go like this. So over here, we're going to have intervals, and over here, we'll have integrals. And just see how they differ. So let's draw just an x-axis, like right there. And let's have this point, let's have 3 points. And this will be A, B, and C. So you're just looking at the intervals here, from A to B, from B to C, but then also you have an interval from A to C. And you also could be going in the other direction. But basically, guys, if you take the interval with endpoints A, B, and add to it BC, then you will get the entire interval AC. Okay, so that's like interval addition. But you can also do subtraction. So if you took the whole thing AC and you subtracted like one of the smaller pieces, for example, AB, you would get BC. Okay, so that's how those work. Now with integrals, it's kind of similar, except I'm not just thinking about the intervals themselves. I've got a graph. All right, let's just say it's above the x-axis. And so this here, like that. Okay, so like this space here, that's the area of the integral from A to B. This is that area is the integral from B to C, but if you added both of these areas, you'd get the total area from A to C. So with integrals, it looks like this. If you take the integral from A to B of f of x dx plus the integral from B to C, that is equal to the integral from A to C. Okay, and then let's do a subtraction version. So you could take the integral from A to C, and you could subtract from it either of the smaller integrals. We'll just do from A to B. And that's going to equal the integral from B to C. Dx. Okay. And guys, very often when you're just kind of like working it out, like, you know, doing some like side work, it's easier just to think about the intervals themselves rather than the entire integral. Okay, so anyway, let's do 2 examples. So let f be a continuous function. That's important because otherwise the integral doesn't exist. You can't take the area under, you know, if we're not continuous. So let f be a continuous function such that the integral from 2 to 8 of f of x is 7, and the integral from -9 to 8 of f of x is 11. What is the value of the integral from 2 to -9 of f of x? Okay, so guys, this is what you do. Just do like an interval. We're just going to figure something out here. And we've got 3 numbers, 2, -9, and 8. So put them here in order. So -9, 2, and 8. Now look at what you're trying to find. We're trying to find the integral from 2 to -9. So if that is a forwards interval, you need all of the integrals to go forwards. But if it's backwards, vice versa. So from 2 to -9, so this is a backwards interval. Okay, so that's a backwards interval from 2 to -9. Okay, and so what we're dealing with here, guys, are really 3 intervals. We've got these 2 small intervals, and then we've got this larger interval from -8 to -9. So we need all of our endpoints going in that direction. So we're going to look at the ones that we are given. 2 to 8, nope, that's forwards. So guys, what you do is you could switch them 8 and 2, but that would make the answer negative. Okay, so you could switch the base's order, but that's going to change the sign of the total area. How about this one? -9 to 8. That's also going forwards. So 8 to -9. And then that's going to be -11. Okay, so make everything go in the same order. Then take what you're finding and write it down. We've got to use notation, nice notation throughout. All right, so that's what we're finding. And then you're going to write an equation, an integral equation with this. So what is this equal to compared to like the other integrals we have? So this integral from 2 to -9, this is one of the pieces. So one of the subintervals. So we could take the whole interval and subtract from it this one, and we're going to end up with what we want. So this is equal to the integral from 8 to -9 minus the integral from 8 to 2. Okay, so you need to write that sentence there. And then you see if they've given you what you need. Okay, so right here, this integral, I know it's -11. And then this one as well, I know, and that's -7. So this entire integral is -11 minus, this entire one is -7. -11 plus 7 is -4. So that is the answer. Okay. All right, let's do another one. So let f be a continuous function again such that the integral from 7 to 1 of f of x is -2 and the integral from 7 to 10 of f of x is 3. What is the value of the integral from 1 to 10 of all of this here? Okay, so let's just look at what we're dealing with. We've got our endpoints are 1, 7, and 10. So I'm going to start off going like this. So we've got 1, 7, 10. Okay. And let's just make sure, all right, so this is what we're being asked to find. So I'm going to have to do some moves because this is not as straightforward as the last one. So I'm going to have to do some moves on this final expression. But let me just look. I know that I'm going to need to be thinking about integrals going forwards because of this integral here that we're asked to find. So from 1 to 10, that's forwards. So any other integrals I'm giving, I need them to be going in the same direction. And so 1 to 10, that's like this entire integral, and it's going forwards. Okay, so so the parts here are 1 to 7. I'm going to need that going forwards, and then 7 to 10. All right, 7 to 10 I've got here. That's going in the right direction. But 1 to 7, this one is 7 to 1. So you could switch them. So that's going to be 1. That's going to be 7. So 1 to 7. But then instead of that being -2, it's going to be +2. Okay. Alrighty. So, guys, I'm just looking at this. I see that I'm going to break this up. This has 2 terms. I'm going to end up breaking them up. And ultimately, I'm going to need to know the integral from 1 to 10 of f of x. I'm going to need to have that piece of information. So I will, let me set that up with notation. So I'll need the integral from 1 to 10 of f of x. Okay, so you take what you know that you're going to need, and then you write like an integral equation. So from 1 to 10, that's the entire thing. This is going to be equal to the integral from 1 to 7 plus the integral from 7 to 10. Okay, you need that statement there. Okay, so we actually have both of these, so we can find that. So the integral from 1 to 7 and the integral from 7 to 10, we're going to be needing those. And, okay, integral from 1 to 7 is 2. And then from 7 to 10 is 3. So that's 5. So the integral from 1 to 10 is 5. Now let me take this that I'm trying to find. So this is, all right, so from 1 to 10, f of x. Okay, and we could use rules here. So let's break this up. This is the integral from 1 to 10 of 2f of x dx minus the integral from 1 to 10 of 5 dx, okay? And then furthermore, I could take this 2 out front. So this is 2 times the integral minus, okay. Now, the integral from 1 to 10, we already figured out that that was 5. Okay, so this entire thing here is 5. So we've got 2 times 5 minus, now this here. Guys, this is the integral of a constant function. So we talked about this last lesson. The area, so this integral here is literally the area of one rectangle. Its base is from 1 to 10. So the base of this rectangle from 1 to 10 is positive 9. The height is whatever constant function is in here. The graph of this is a horizontal line, which is 5 units above the x-axis here. So the height is 5. And if you think for your notes, it would help you to write that down. All right, for the integral of a constant function, you just literally do base times height. It's a rectangle. So this is 10 minus 45 is negative 35. Okay, there's that.